Here we'll work out two sample problems related to sequences. So the first is a basic one, wants us to write out the first 6 terms of the sequence. Bn is n plus 1 over n. And this just results in plugging in the numbers between 1 and 6 into this expression here for Bn. So we'll see that for part 1. We have B sub 1 is 1 plus 1 over 1, or 2. B sub 2 is 2 plus 1 over 2, or 5 halves. B sub 3 is 3 plus 1 over 3, which is 10 thirds. B sub 4 is 4 plus 1 fourth, which is 17 fourths. B5 is 5 plus 1 fifth, or 26 over 5. And B6 is 6 plus 1 sixth, or 37 over 6. And for part 2, we're going to the limit as n goes to infinity of square root of n plus 3 minus square root of n. And we're given a hint to multiply, divide by the conjugate, and then simplify. So for that expression, we want to find limit as n goes to infinity, square root n plus 3 minus square root of n. And the hint says multiply top and bottom by the conjugate. So that would be square root of n plus 3 plus square root of n over the same thing. If we multiply that out, the top part is a difference of 2 squares. So we'll see limit as n goes to infinity of square root n plus 3 squared minus square root of n squared over the denominator of square root of n plus 3 plus square root of n. But this on top just becomes n plus 3 minus n over square root n plus 3 plus square root of n, which is limit n goes to infinity 3 over square root n plus 3 plus square root n, because the n's up here will cancel when I subtract them. If we look at this here, we can clearly see that as n goes to infinity, this bottom part keeps getting bigger and bigger. There is no cancellation. I am just adding square root of big number plus square root of big number. That's just going to get bigger and bigger as n goes to infinity, so that's going to actually go to infinity. So the bottom part here gets bigger and bigger without bound, going to infinity, which means my entire expression here goes to 3 over infinity, or in this case, that comes out to be 0. We did nothing too out of the ordinary, nothing weird happened, so what this tells us then is that the limit as n goes to infinity of the sequence root n plus 3 minus root n is in fact 0. That's how you'd work out those two problems involving sequences.